Good morning, madam. Myself, I am Sandhya. Today, I am going to explain about recursion introduction in Python. So, first of all, what is meant by recursion? As we know that a function calling itself is called a recursion. The function definition at the function call inside the function definition, again we will call the same function. So that we call it as recursion. So it is also called as self-calling function. So there is one important thing is there must be two cases. One is base case and another one is recursive case. So let us see one by one. First one is base case. We are saying that the recursion is function calling itself. So every time if the function calls itself, automatically it will be going to the infinite recursive call. So there will be no end. Every recursion should terminate after some finite recursive calls. For that purpose, for that termination, we will write some base class. After finite number of steps, every recursion function should be terminated. That means it should start its recursion. So the next one is recursive case. Here, it will keep on calling the function itself. Here is an example for it. The best example for the recursion is factorial. Let us take 5 factorial. We can write this 5 factorial as 5 into 4 factorial, 5 into 3, 5 into 4 into 3 factorial, 5 into 4 into 3 into 2 factorial, 5 into 4 into 3 into 2 into 1 factorial. So after finite number of steps, it will return 1 and it will return the results. It will return the results and it will return the results. Every time we are applying the factorial, we will write just like calling the same function. So the important thing is to remember one is base case. It is for terminating the recursion. And another one is recursive case. It is for calling itself. So let us see one example program for it. Factorial using recursion. Factorial using recursion. So def factorial of n is passed. If n is equals to 0 or n is equals to 1. So in the both cases, the answer is 1 because the 0 factorial is 1 and also 1 factorial is 1. So here we can write it as return 1. Else repeat the same procedure. Return n into factorial of n minus 1. N is equals to int of input of enter n value. Results is equals to factorial of n. Print results. So here it will return the results automatically. So let us trace it. So here we are taking n as 5. See, n into factorial of n minus 1. That is 5 into factorial of 5 minus 1 means 4. No? So here we will see 5 is not is equals to 0. 5 is not is equals to 1. So the condition is false. We are going to the else part. So now let us say 5 into factorial of 5 minus 1, that is 4. So now results is equals to factorial of 5. So 4 is not is equals to 0. 4 is not is equals to 1. So this condition is also false. So we will go again, we will go into else part. So here 4 into factorial of 4 minus 1 means 3. So again we will check 3 is not is equals to 0 and 3 is not is equals to 1. So this condition is also false. And we are going to else part. So 3 into factorial of 3 minus 1 means 2. So here factorial of 2. 2 is not is equals to 0 and 2 is not is equals to 1. So again we are going to else part. 2 into factorial of 2 minus 1 means 1. So here 1 is not equals to 0. But 1 is equals to 1, no? So let us stop it here. So it means 2 into 1. 2 into 1 is equals to 2. 3 into factorial of 2 means 2. So 3 into 2 is equals to 6. And 4 into factorial of 3 means 6. 4 into 6 is equals to 24. So 5 into factorial of 4 means 5 into 24. Here 120. So automatically it will print the results as 120. So at last, coming to the conclusion, the two things we have to remember in this recursion, base case and recursive case. After some finite number of recursive calls, every recursive function should be terminated. Here, there is no much complexity in the recursion. Just only one complexity is we have to identify the base and recursive case. If we find this base case and recursive case, the logic will be very simple. Okay, thank you. Thank you, ma'am.